Hello, this is Mr. Stewart, and I'm coming to you with the 2.2 quiz. This video that is right here, this is what I'm redoing. We redid the quiz a little bit, so I'm redoing the video as well. So let's just start it. And I think this quiz, I put a lot of emphasis on using calculators, and I think calculators are valid. But when I say use a calculator, I don't mean...
Braden Jones, please come to the front office.
So I don't mean, our fancy computers or calculators that we have here at the school. They are nice because they have fraction buttons, and so students are using those in the classroom, but I don't want to set up our students to be able to only be able to work with fractions if they have a very specific kind of calculator that makes them dependent on that one kind of calculator. So I want to talk to you guys about what's going on here with these questions, and hopefully just kind of show you a logical idea. And when you're looking at, this is a positive 4 7/10, and then you look at the next number, which is a negative 9/11. So if you think about it on the number line, you've got yourself a number line here. Here's 0, and you're going in the negative direction. You're going in the positive direction. In the positive direction, you're going 4 7/10, right? Just right there, you're thinking, okay, this is a positive direction. And then from here, you're going in the negative direction, 9/11, which isn't even one whole. So it's not even taking you, it's just, we would say, just like a tiny amount in this direction. And just understanding that right here makes it a little bit better for you to understand. There's a few that you can eliminate right off the bat. There's at least 2 answers here that there's no way 2 of those answers could be, because we know that whatever this answer is right here, wherever we landed, whatever that happens to be, it's going to have to be a little bit smaller than this number. And so just kind of using logical patterns, you can make things a little bit easier for yourself that way. But at this point, then, you're still going to have to do addition, subtraction, whatever. And so what I'm going to do is just going to make up one, and I'll make it really easy. And I'm going to do 1 2/3 plus a negative, and I'll just make something, 2/5. I'll say 2/5. All right. And so again, this is following the same pattern, but they're just different numbers. And what I'm going to do here is I'm going to first convert this to an improper. This is in mixed form right here. This is mixed, okay? But I need this to be in an improper form, and that's going to be super helpful. So if I think about this whole number, if we're working in thirds, represents 3/3. 3/3 equals 1 whole. So that's why they could say they do the around the world thing. They say 3 times 1 plus 2. So I've got 3/3 plus another 2/3. So how many thirds total do I have? I've got 5/3 total. Or in other words, 1 2/3 is the same as 5/3. Okay. And then that's added to 2/5, a negative 2/5. Now this negative here, that's important, right? When we're working with integers in chapter 1, let's say if like a 5 plus a negative 2, if we said that, remember the answer is going to be positive because the 5 is farther from 0 than the negative 2. I go up 5, and then I go back 2. And so, just remember that still is the case even with rational numbers. So let's change colors here, and let's just keep going with this. Now, I need the denominators to be the same. I can't just add straight across 5 plus 2 and 3 plus. I just can't do that. That doesn't work that way. Fractions don't work that way. And if you need a reason why, there's some videos I can show you that explain what fractions are. We worked with these in class. We need these denominators to be common. We need them to be broken in the same sized pieces before we can start adding those fractions together. And a lot of times, the quickest way to do that is just find the product of these two numbers. 3 times 5 is 15. 15 is a common multiple of both 5 and 3. All right, so 5 it can cleanly or evenly go into 15, and 3 can evenly go into 15 as well. So then we just think, okay, if I changed this denominator right here to 15, what did I have to do to 3 to get to 15? I had to multiply by 5. If I multiply the numerator by 5, in order to keep the fractions equivalent, and you're going to hear that word a lot, equivalent, E-Q-U-I-V-E-L-A-N-T, I want to say. I might spell that wrong, but there's no spell checker on when I'm handwriting. So, equivalent, in order to change this fraction to be an equivalent fraction with 15 as the denominator, I have to do the same thing to the numerator. So I have to multiply by 5 as well. So I'm going to get 25 15ths. Okay, and I'm still adding that together. And this is still a negative. Don't forget that part. That's still a negative. And now I just look over here and I do the same thing. What did I have to multiply by 5 to get to 15? And you would say, well, 5 times 3 equals 15. So that means I have to do the same to the numerator as well. And then that would be, 3 times 2 is 6. So I've got 6 15ths here. I've got 25 15ths plus 6 15ths. Now that the denominators are common, now that they're broken up into the same sized pieces, now I can add them together. So this is going to be equal to the 15, that's going to be the sized pieces that everything's broken into, so that stays the same. On the top, I've got 25 plus, this is where students will miss, a negative plus a negative 6. Plus a negative 6. This is where students kind of fall apart on the fractions with negatives, okay? Because in 6th grade, they were taught how to add and subtract fractions, but they were never really working with negative rational numbers before, and that throws students off. But this is no different than up here, at least I'll say up here, this is no different than chapter 1. We already know how to do 25 plus a negative 6. We know what that is. That's going to be 25 in the positive direction and then 6 backwards. So that's going to take us to a positive 19. And the denominator stays the same, and there you go. Now there's one more thing with this style question. You'll notice that all of the answers here are what we call mixed. They're mixed. They're not improper. The answer we got here, where the numerator was larger than the denominator, this is what we call improper. And most of the multiple choice test questions are going to require you to convert this back to an improper. Now there's a few logical things that you can use to help you eliminate some of the answers here, and so a lot of times you won't have to go through this entire process, but I wanted to show it to you at least one time. So 15 19ths. That means that really I've already got, let me just I'll move up here. So I'm going to be working up here now. Okay. I've already got one whole, because if you think about it, I've got 15 15ths already. In fact, I've got 19 15ths, but if I stop at 15 15ths, that means that's just one whole, right? So 15 goes into 19 one whole time. So I've got one whole, and then what's left over is after I did 15, I had 19 15ths, but I stopped at 15 15ths to get one whole. And then what is the difference? Like how much is left over from the 19 after I did 15, 16, 17, 18, 19? So there's actually 4 left over from the 19, and that's still going to be over the denominator 15. So this is how you go from an improper to a mixed. And so I guess I should be careful with the way I write this. This is actually, so 19 15ths is the same as 1 and 4 15ths. Or 15 goes into 19 one whole time, and then with 4 left over, and still over the denominator 15. This is, of course, my answer. It has nothing to do with your answer here, other than the fact that if you were solving this by hand without a fancy pants computer or a calculator, this is how you'd be solving it. Okay, not going to spend a lot of time on this one. Any 9-digit calculator should be able to do this. Remember to line up the decimals, and just remember this is a negative plus a negative. Think about this on a number line. You've added a negative, that's your first negative, and then you've added, it's a small negative, but it is still just a negative, and so you're continuing down the negative path. So just remember that, and then just line up the decimals, add them together, and don't forget to tag on the negative at the end, and you should be fine. Okay, with substitution, I think if a student's going to miss this, it's not because they don't know how to do fractions, it's because they'll substitute incorrectly. I'm going to write this bigger so that you can very easily see this. This is x and take away and y. And what I'm going to do is we're going to just use some colors here to kind of show you some things. X is equal to 2/7, and y, it's telling us, is equal to 2/3. So what we're going to do is we're going to substitute x in, 2/7 in for x, and then we're going to substitute 2/3 in for y. Notice the one thing we didn't touch is this thing right here. This operation just stays. It's just going to be there still. So if you think, I'm just going to leave this down here, and now I'm going to say this. Instead of writing x, I'm going to write 2/7. I've substituted this number in for x. Where x is, or where x was, now there is 2/7. The negative comes down, or the subtract, however you want to think of it. And then y is now being replaced with 2/3. Now at this point, this is just you're adding. I mean, you're subtracting. I know, but let me put it this way. Remember, when we were working with integers, and we gave you something like this over here. I'll say 2 minus 7. We talked about and we worked on the idea that every single subtraction question can be converted to an addition question as long as you treat these as integers. So in a way, this is a term which becomes 2, and this is a term which is a -7. And you can add them together. In other words, 2 take away 7, which happens to equal -5, I think, yes, is the same as 2 plus a -7. That also equals -5. So what we're looking at here is just a term. This is a 2/7 plus this term, which happens to be a -2/3. Students start freezing up when they see fractions and they think, oh, well, that doesn't apply, like these are different. But you don't treat them any different. They're still numbers. So all we're really doing is doing 2/7 plus a -2/3. And that is completely doable, I think, by hand. We've been working 2 to 3 days in class just on doing these by hand. So again, if you don't have a fancy computer calculator, you should still be able to do this. But I think that'll help a lot. Okay. I wanted to look at this substitute question with you guys as well. And that's because of the negatives, and that could throw a lot of students off. So I'm going to put a negative, and then I'm going to put x, and then a subtract, and then y, and then again we're going to use these colors here, and we're going to say, okay, x is equal to 3/8. So this is going to replace. Actually, I don't want to go that way. This is going to replace what x is. Now watch what happens. Notice it's only replacing x. It has nothing to do with the negative out here. Right. So if I rewrote this, I would say minus, and then the x now becomes 3/8. So this, in a way, this is just saying this is a -3/8. Okay, that's fine. That's the same thing. And again, watch. This negative comes down. And all we're doing is we're focusing on the y. We're focusing on the y here. Y is equal to a -3/4. It's going to replace what y was. Y was y, but now it is a -3/4. If a student misses any question on this test, it's probably this one right here. They probably misunderstood this one thing. Now when you bring everything down, this is just, think about what happens here. Try to remember from chapter 1, try to remember from chapter 1 what happened when, let's do like, I'll say like a -5 minus a -2. Try to remember what happened here. The negative 5 stays the same, but what happened when we have two negatives? The opposite of the opposite. The opposite of the opposite is a positive. This becomes a positive 2, and now we're left with so that equals negative 3. Well, same thing here. This is the opposite of the opposite. This is an opposite 3/4, but what's the opposite of a negative 3/4? And you would say it's a positive 3/4. So does this look a lot more manageable, a lot more doable? I would say absolutely yes. It's a lot easier to work with now. You're going to have to change the denominator or convert the denominator, probably just this one, so that it matches this one, and then just add. Remember this is remember to keep it as an equivalent expression. And if you forgot how to add fractions, go back to number 1 and rewatch that one again. And then finally, this one right here, this is going to just take you some time to find common denominators. Yes, if you have a calculator, use it. I'm okay with that, but let's just think about this logically for just a second. This is close to 8, just a little bit above 8. This is close to 9, just a little bit below 9. But they're very close in numbers. And there's going to be a little bit of cancellation happening here because this is positive and this is negative. So you're going to be left with just a little bit of a negative number, just a small negative number, and then you're going to add that to another negative number, which is 6 and 5/6. So you've gone negative 6 and 5/6, and then you're going to add a little bit of that negative left over between these two after they cancel each other out. So it's going to be around here. I mean, if you're just doing a quick estimate, there's a few that are just outright gone. Like it couldn't be anything closer to 0 than negative 6 and 5/6. So it couldn't be anything on this side. So that eliminates at least one of them. And then it couldn't be anything like outrageously far this way or outrageously far this way. So it couldn't be a positive answer as well. So really, you've only got two choices here. Yeah, really, there are only two logical choices, and this is one of the things that this test shows: is how good are you at logical thinking? And I'm going to leave you there, and hopefully this is very helpful for you. Thanks for watching.